Okay, so guys, in this lecture we'll be continuing on seeing the nomenclature of organic compounds, and we'll be seeing the remaining part on to name the organic compound which was left, such as the word root and the 1 degree suffix. Okay, so let me start off with the 1 degree or the word root first. Okay, so word root. Okay, so in the word root, if we have one carbon chain, then it's called meth. Similarly, we can say that for C2 we have eth, C3 we have prop, C4 we have but, C5 we have prop. Okay, C5 is not prop. C5 is pant. C6 is hex. C7 is hept. C8 is oct. C9 is non. C10 is dec. C11 is undec. C12 is dodac. C13, or let us just see C20 only. C20 is ICOS, and C100 is hect. Okay, so now let's look at 1 degree suffix. Okay, 1 degree suffix is if the parent carbon chain is saturated or unsaturated, then 1 degree suffixes are to be attached at the end of our naming convention. Okay, so 1 degree suffix can be for an saturated organic compound, we put as ane in the last, and for unsaturated organic compounds we put okay, unsaturated can be alkene and as well as alkyne. So for alkene we put ene, and for alkyne we put ine. Okay, so let us look into how do we actually do the naming of certain organic compounds. So we'll be looking at some of the rules of the nomenclature of alkane. Okay, starting off with nomenclature of alkanes. Okay, so the first rule is selecting the longest carbon chain, which is also known as the principal carbon chain. Okay, so please remember that the longest carbon chain in an organic compound is not always a straight chain. Okay, let us look into some of the examples of what I mean when I say that. So let's say we have a carbon chain okay, and at the fourth carbon we have something like this is the organic compound which I was talking about. So if you calculate the chain, so this is 1 2 3 4 5 6 7. Okay, so this chain actually has 7 carbon atoms in it, right? But if we just calculate 1 2 3 4 5 6 7 8, right? So according to the rule, this chain should actually be selected for our to qualify as our longest chain, right? So just writing those things in words, that the first rule says that you have to select longest carbon chain which is also known as principal carbon chain. So in this case, the length of our principal carbon chain in the above compound is 8 and not 7. And there is some point to be noted that longest carbon chain is not always a straight chain. Okay. So let us look at some more examples. So you have to calculate the longest or select the longest carbon chain from this compound. Okay, so let us start the numbering here. This is 1 2 3 4 5 6. If I select this carbon chain, then it would be 6 number of carbon atoms present in this chain. If I select this carbon chain, then this carbon chain will be having higher preference over the lower carbon chains, as it has 7 number of carbon atoms. If I choose this carbon chain, then it has 5 6 7 8. Okay, so this is the highest number of carbon atoms that I can get in any chain possible in this particular organic compound. So just highlighting this chain, so we are picking up this chain as our principal chain, or the chain which contains the maximum number of carbon atoms possible. Okay, so let us consider this scenario. Okay, so in this case, if we count that number of carbon atoms in the straight chain are 7, and also we get the same number of carbon atoms in the second chain, which just falls down. So in this case, how do we select which carbon chain to be getting selected as our principal carbon chain? So whenever you find a conflict like this, just remember that in case of two same carbon chains or the same length carbon chain, select that chain which has more number of substituents attached to the chain, right? So in this case, I have only one substituent. So had I selected this carbon chain, then this carbon chain only had one substituent at the 4th carbon position. So this chain has one substituent. But if I select this carbon chain, then I have 3 substituents attached to the 4th position carbon atom in the second chain, and we have one substituent here, one substituent here, and one substituent here. So in this chain we have 3 substituents. So what chain I'll be using for the naming of this organic compound? I'll be using this chain. Okay, I hope you are following. Okay, so this was actually the second rule, in which I have to write it down formally, that in case, okay, so in case of two similar length carbon chain, select that chain which has maximum number of substituents attached to the chain, to substituents attached to the chain. Okay, so let us look into the third rule of nomenclature, as in case of alkanes. So the third rule, this was the second rule, the third rule is LPN, or lowest of the possible numbers, right? So select a carbon chain so that the locant or the substituent must get lowest number in the carbon chain. So what do I mean by the lowest? By lowest I mean that start numbering the carbon chain in such a way that your substituents are get substituted at the carbon atom which is low in number, right? So let me give you an example of the same. Let's suppose I have a carbon chain like this. Okay, so it is pretty much clear that only this would be treated as my principal carbon chain, or the chain which has the most number of carbon atoms. Now what the third point tells is you have to number this carbon chain in such a way that this substituent is numbered as the least possible number of this carbon atom. Okay, so what do I mean by that? So if I start numbering the carbon chain as the first carbon atom from here, so 1 2 3 4 5 6 7, so by this numbering order I get that the substituent is attached to the fifth carbon atom. But if I reverse the, or if I redo the numbering order, I can also start from this carbon, as marking this carbon as the first carbon atom in the chain, right? So this is the first, second, third, fourth, fifth, sixth, seventh, right? Starting from this carbon atom as the starting point of the chain. So according to the third rule, I should select the second chain numbering as my chain numbering. Why? Because the substituent this C is attached to third carbon in the second chain numbering and to the fifth carbon in the first chain numbering. Although the chain was the same, but just in the numbering sense, the second chain, the chain should be numbered like the second chain, or the numbering should be similar to as how we are numbering the chain with this order, starting from this carbon atom as our first carbon atom. Okay, so let me give you more example on the third rule. So let's say we have chain like this, and we have substitutions at this is our substitution. Okay, so from where do I actually number the chain? Okay, so if I start numbering from this carbon atom, I would get numbering something like 1 2 3 4 5 6 7 8. Okay, so according to this chain we have 3 and 5 carbon atoms which are having substitutions, right? And if I start numbering from this carbon atom, I will get numbering as 1 2 3 4 5 6 7 and 8. So according to this carbon chain we have substituents at the carbon positions at 4 and 6. So in the minimum of the two, this is lower than 4, right? So this carbon naming convention will be following for the chain as 3 is less than 4. So we can find the first substituted group at third position in this chain rather than fourth in that second numbering chain. Okay, so we'll be using this for our numbering convention. Okay, what if we have something like this, that we have 4 straight chain connected carbon atoms, and we have chlorine and bromine here. So if I took the numbering chance, then it could be 1 2 3 4 and 1 2 3 4. In both the cases we have 2 and 3 as the substituent in the first ordering and in the second ordering. So how do you actually pick up which ordering to take? So in such case of conflict, we just pick up the chain in which we see that what substituent are added at the second position and the third position. So for the second position we have bromo, or for the third position we have bromo. Similarly we have chloro. So as in alphabetical order B comes before C, so B would be given higher priority. So numbering would start from this carbon, or the second degree, or the second number of the second carbon would have bromo as its substituent. Okay. So just to put it formally, then you can say that if either direction leads to the same least number substituent carbon atom, then number the C chain on the basis of alphabetical sequence of the substituents. Okay. So in next lecture I'll be delving on some of the examples of the IUPAC names, so you will get more clarity then. Okay.